Okay, homework 14. Question tells us that this line here and this line here are perpendicular. So we know if we can work out the gradient of this line, then it should be easy to find the perpendicular gradient for this line here. That means the first thing we need to do is we need to take this equation, write it as y equals. Once we write it as y equals, that identifies the gradient. We can then find the perpendicular gradient. Question 2, the recurrence relation. un plus 1 is 0.2 of un, add 9. Now the recurrence relation, what that means is that u2 is equal to 0.2 of u1 plus 9, and then similarly u3 is 0.2 of u2 plus 9, u4 is 0.2 of u3 plus 9, and u5 is 0.2 of u4 plus 9. Now I'm going to work backwards from the u5 one so that I can find u3. So I can find this one here. How am I going to do that? Well, the question tells us that u5 is 11. So I'm going to put 11 in for u5. So 11 equals 0.2 of u4 plus 9. If I solve that, I can find out what u4 is. And then if I substitute that in here and repeat the process again, I can then work out what u3 is. So work backwards twice. Question 3. P, Q and R are collinear. You have to find a ratio in which Q divides PR. So we need to work out PQ and we need to work out what Q to R is. Q to R is fortunate. I've told you what that one is. It's 2 minus 4, 6. You know how to work out P to Q, little q minus P. Get these two answers and there should be some sort of connection between them. The connection between them is the ratio. Question 4. Solve this equation. Well, we can do that. Do your all sine tan cos diagram. Tick your little boxes, work out your answers. Now, the important thing about this question is the range. Your answer can only lie between pi radians, which is 180 degrees, and 3 pi over 2, which is 270 degrees. So that means that we're looking for the answer in this quadrant here. Okay, and it's only one answer we're looking for, and it's in the T quadrant. Remember and write your answer in radians. Right, do not do it in degrees. Question 5. You've got the point R. We know what R to S is, and we have to find T. So R to T is little t minus little r. 3 lots. R to S is given in the question is 2 minus 1, 3. Also given in the question is the point R, so we can take that away and we can write in there that that is 3 minus 1, 2. And if we solve all that out, we can work out what T is. Now the question is asking you for capital T, so that's the point, so remember and write it as a coordinate. Question 6. Cos x is negative 2 over 5, so we're going to start with this question. Pythagoras to give us this side here, and then we have to work out cos 2x, so use the expansion cos squared x minus sin squared x, put your fractions in and work them out. Question 7. Find an expression for t, basically just solve that equation, so just get what t equals. You know how to get rid of the e to the power, then it should be quite trivial, I think, to do that one. Question 8. You've got a circle. We can write down the centre of this circle is half the x number with the sign changed, half the y number with the sign changed. We can work out its radius as the x number squared, add the y number squared, take away the number at the end. Now the important point about this question is we need a diagram. Okay, we know that it's centred on 6, 5, so 6 along, 5 up. We also know that it makes the coordinate axis in 3 places. So if that's the centre, then our circle could look like that. Isn't, because it doesn't touch the axis, so let's get rid of that one. It could look like that. This one touches it in 2 places, or it could look like that. And this one touches it in 3 places. So basically we need to work out what the radius of that circle is. Once we know the radius of the circle, put it equal to this formula here, and then remove the square root signs and tidy up, and you'll be able to work out what k is. Question 9, solve the equation. First thing you need to look at here is this value of 3. Okay, you're not allowed to have just a number on its own in there. It has to be written in terms of log to the base 2. So the first thing you must do with this question is leave the original as log to the base 2 of 3x add 7, and then rewrite 3 as 3 log to the base 2 of 2. And then write your last part down, log to the base 2 of x minus 1. Okay, now you've got log to the base 2, log to the base 2, and log to the base 2. That 3 can go up as a power. You know what you do when you add logs. So your left hand side still says log to the base 2 of 3x add 7. Your right hand side is simplified down to log to the base 2 of something. You can work that out. Now, because you've got log to the base 2 on each side, these log to the base 2's, they don't cancel each other out, but you can remove them from each side, and then you're left with 3x plus 7 equals whatever your little expression here is, and you can solve that to get x equals. Question 10, it's quite a long question. Show the equation of the altitude from C. So the altitude from C. Now to work out an altitude, we work out the gradient of the opposite side, which is AB, and then we get the perpendicular gradient. Then we use that perpendicular gradient and the point C, and we plug them into the formula y minus b equals mx minus a. Okay, so you should be able to do that, and that should give you the answer for part A. Part B, find the coordinates, find the equation of the median through B. So that's a line that goes through B and cuts this in half on this side here. So if you're trying to find the median, then the processes we go through there is find the midpoint of AC, find the gradient between B and that midpoint, let's call it D, and then use the gradient that you've just found and the point B in the formula y minus b equals mx minus a. And then for part C, if we just do simultaneous equations on those two answers that we've got, then that should tell us the coordinates of this point here where both these lines cross. Question 11, functions f of g of x. So put the g into the f formula. That shouldn't be too difficult for you to do. Tidy it up, so remove all the brackets and such like. Once you've removed all your brackets, you'll have something along the lines of x squared plus a number times x plus a number at the end. Okay, you can work out what those numbers actually are. For part B, we then complete the square on that, and we know how to do that. And then for part C, what values of x cannot be in the domain, because this complete the square has gone down the bottom, is at any time where the bottom equals 0. So put your completing the square part, put your p bracket x plus q squared plus r equal to 0 and solve. and then that will tell you any x numbers that the function cannot take. And hopefully that should be you finished.